everyone, welcome back. Before we get into the lipid-derived second messengers in detail, I think we should at this point clarify what our inositol ring looks like. So here's the structure of an inositol ring. It's basically a cyclohexane with hydroxyl groups on each carbon. Okay, and because all the carbons have the same group on each one of the because all the carbons have hydroxyl groups on them, you can start numbering them from anywhere. So I just randomly chose this is 1, 2, 3, 4, 5, 6. Okay, so well, here's our inositol ring. How does it go about turning into a second messenger? So we have all these are the key players: phospholipases, phospholipid kinases, and phospholipid phosphatases. What do these things do? Let's look at them in a little bit of detail right now. So phospholipases, phospholipases. Phospholipases are enzymes that split lipids. So they are lipid splitting enzymes. Okay, so anything like with an ases is always something that splits. I can't think of, like, don't go with kinases because kinase definitely doesn't split stuff, but something like can't think of a better example. But anyway, so lipases for now is lipid splitting enzymes. Okay, um the next one is phospholipid kinases, and this should be pretty clear because I mentioned many number of times that kinases are something that add a phosphate group, so they are lipid phosphorylation enzymes. Lipid phosphorylating enzymes. Okay, and the third one is phospholipid so they just do the opposite: phospholipid phosphatases. Phospholipid, big words, huh? Phosphatases. So these phospholipid phosphatases, they are, as you can guess, lipid dephosphorylating, oh sorry, dephosphorylating enzymes. Okay, so these are the main three enzymes. I'm not sure if there's more or less. Well, can't be less, it has to be these three at least, but I don't know if there's more, but these ones are the most important ones: lipid splitting, phosphorylating, oh phosphorylating, dephosphorylating. Okay, so now let's look at them in detail. At least we can get by finishing phospholipases. So phospholipases, and this might seem a little bit of like repetitive, it might be redundant, but I do that purposely because all this is memory work, and the more you study it, the more you read it, the more you look at it, the better you will be at remembering this stuff. So phospholipases, they are enzymes that hydrolyze. So remember, they are lipid splitting, right? So they somehow need to break the lipid into parts. So how do they do it? Well, they hydrolyze specific ester bonds that connect the different blocks, that connect the different blocks that make up a phospholipid molecule, that make up a phospholipid molecules. Now, what does a phospholipid molecule look like? A phospholipid molecule starts off with a head group attached to a phosphate, attached to a glycerol, attached to two fatty acids. And I'll draw a neater picture in the next video. This one's coming to an end. So let's discuss more about this in the next video. See you guys there.